Hi everyone, welcome to the second Racetrack Builder video. Today we're going to be talking about mesh templates. Now, a mesh template is a Unity object that tells Racetrack Builder how to convert your series of curves into a racetrack model. So it contains some meshes that will be fitted or warped to the curves, and it can also contain objects that will be repeated at regular space intervals, which can be used for things like supporting poles. So the starting point for this video, I've created an empty Unity project. I've imported the Racetrack Builder asset from the asset store, and I've created a simple scene with a looped track. And I've also added the car from the Unity standard assets package, so that I can test it out. So all of this was covered in the previous video, and it's also in the documentation as well. So before we begin, just a quick recap. Our Racetrack Builder comes with a bunch of track templates already, and those are available in the Racetrack Builder Prefabs Track Templates folder. To use them, you select a curve, and then you drag your template onto the template slot, and that sets the track type from that curve onwards. So if we just update the rest of the track, there we go. You can also change the track type midway through. If we select a curve in the middle of the track, and drop a different track type on there. So that's just the basics of how to use the track templates. So we're going to be creating a track template from scratch. However, before we get into that, I'd like to quickly show you how you can modify the existing templates. And it's fairly straightforward. It's standard Unity editing and saving as prefabs. Let's just clear the template from there. We'll use the asphalt poles barrier one. And that one takes a little bit longer to apply to the track because it's got more meshes. Okay, so let's say we want to decrease the spacing between the support poles, and perhaps we only want to have the barrier on the left hand side. So we can start by dragging our prefab and just dropping it into our scene. Move it down slightly so we can see it. And what I will do is I will actually select the first curve, and I will drag the object from the scene into the curve. And now we can basically edit our object. I'll just give it a name. Just call it 2 to be simple. Right, and we can edit the spacing. Now this Racetrack Spacing group component will go into a bit more detail later, but right now we're just going to set the values to 10. Before and after is 10, so that's 20 between each one. And if we go to our racetrack, just to save time, I might just update the first curve. And we can see the spacing. They are now closer together. And likewise, if we want to remove the right hand barrier, if we try and delete it, Unity will tell us we can't, because we've got an object that is based on a prefab. It's still based on the prefab, and you're not allowed to remove the components of the original prefab. So that's just standard Unity prefab mechanics, and the way to get around that is to simply unpack it. So now it's just an object. And we can now delete it. to the original curve, update the curve, there it is, and let's just update the rest of the track. Right, so editing the track template is as simple as that, and of course when we're done with it we can drag it, drop it into our project, create a prefab, and we don't need this anymore. Although do keep in mind, if you've deleted the object while it's assigned to the curve, it will say that it's missing. So we need to go back and find our new prefab and drop it in there. Okay, so we're going to create our own mesh template from scratch. We're going to use the existing meshes in the Racetrack Builder package, and that's just mainly to keep it simple. In the next video I'll show you how to import meshes, import your own meshes. Right, for now we'll create a mesh template object, and it's a standard Unity object, so we can just add empty object, my track, or the track type perhaps. Right. So just by itself, that's not quite enough to let us drag it onto the template slot. And that's because the template requires a racetrack mesh template component. So we can fix that. Add the component. And now we're allowed to drop it on. And basically all that component does is marks it as a mesh template so that you can drop it there. So if we update the rest of the track now, it's actually used our mesh template. And it's created these copies of it with a link back to it. But because the mesh template is empty, of course, it means we end up with no track. So let's add a driving surface. Now inside the Racetrack Builder prefabs folder, we have this templates parts folder. We've got a driving surfaces folder. So let's just grab asphalt and drag it on to our track type. And try updating the racetrack again. Now as you see, that doesn't make any difference. And the reason for that is that Racetrack Builder needs a bit of help to understand what to do with the different parts of the mesh template. So there are parts that will be fitted along the racetrack curves and the meshes will be warped, and there are other parts that will be placed at spaced intervals as well. And we do this by marking them out with components. I'm just going to select the track type, just move it out of the way there. So the component that we want for the asphalt is racetrack continuous. And that's the one that says that this mesh is going to be warped along the curves of the racetrack surface. So we update the rest of the track, and it's used our mesh. Now you may notice the road is rather narrow, and that's because the mesh is rather narrow. The default track templates with Racetrack Builder, they actually magnify everything by a factor of 3. So we're going to do something similar. Just to be different, we'll use a factor of 4. We can update the whole racetrack. Now it's worth discussing which transformations applied to the track type actually affect the meshes that are generated. Basically, position and rotation are ignored, however scale is taken into account. And that's mainly because you don't want it to respond to moving your mesh template around. You want to be able to position it somewhere where it's out of the way so that you can edit it. However, it does make sense to respond to changes in the scale, because that gives you a visual clue of how big it's going to be in the track. So now I want to add another mesh, and I'm actually going to add a crossbeams mesh. Now there's a prefab for this as well, however the prefab contains some translations that place it on the left or right hand side, and I actually want to place it on the top. So in this case it's actually easier just to go straight to the mesh. So I'll drop it onto my track type. Need to make a few rotations. That one. There we go. Scale it. Translation, -2 I think we need. There we go. Now, I could add another continuous component to this mesh to mark it as continuous, because at the moment Racetrack Builder won't know what to do with it. However, to keep things simple, I'm actually going to create an empty component, which I will call continuous. I will add the continuous component to that. We'll remove it from the asphalt, and then I'm just going to drop these two objects underneath the object that has continuous component. And what Racetrack Builder will do is when it sees that component, it knows that it applies to all the meshes in that subtree, so all the child objects and their descendants. Let's update the track. There we have our other mesh. And I'm going to carry on. So I've got this horizontal beam. Drop that on there. Do a little bit of translation. Let's be -2. 1.8 maybe, 1.9. And I can duplicate it. And we'll just change that x to +2. That just gives us a couple of beams along the side. Can update the track, and there we have it. And remember, because I've dropped those horizontal beams underneath the object that has the continuous component on it, they automatically inherit that continuous flag, so that Racetrack Builder knows what to do with them. So I want to mention driving surfaces. Now by convention, Racetrack Builder considers the first continuous mesh to be the main driving surface. And the main driving surface, when it builds the track, it gets this racetrack surface component, and that tags it as the main driving surface, but it also contains information about the curve that generated it. Now this is useful for runtime scripts, such as the Racetrack Progress Tracker, as it can then detect when the car is over the main driving surface, and it can also use the information to determine how far along the track it is, and it can use that to put the car back on the track where it last came off. So it's quite important to get the order right. So to illustrate, if we move the cross beams up before the asphalt, and that will make it the main driving surface. So I'll just update the track. So if we have a look now, the cross beams has this component, asphalt does not have component. And this is going to create a problem at runtime because the car is not above the crossbeams. So to illustrate, if we select the car, make sure the Racetrack Progress Tracker component is visible, and just run it. Now you can see that the off-road timer is counting up, so it doesn't realize that the car is on the road. It thinks it's off the road, and that's because it's underneath the mesh that it considers to be the main driving surface. So you can see that once it reaches 10 seconds, it will reset the car. You can also see that the current curve is not incrementing as we drive down the track. Whoops, fallen off anyway. So what this means is it's basically impossible to progress. We're just going to keep getting reset because it never thinks we're on the track. So that's why it's important to be aware of what your driving surface is and to make sure that it's always the first one in the list of continuous surfaces. Now I want to add some poles spaced along the side to hold up the roof. And there's a couple of components you need to do this. So first I'm going to create an empty object called side poles. And the component that we want is called a Racetrack Spacing group. I'll set the index to 2. I'll explain a bit more about that later. But for now we want to set the spacing before to 3 units and the spacing after to 3 units. And that means that the poles will be spaced 6 units apart. Now you might wonder why we don't just have one property called spacing, for example, that we could set to 6. And the reason for that is that when the racetrack starts, and also after a jump, the spacing gets reset. So the spacing before is used to say how far from that point to start placing the objects. And that can be useful because when you've got like the down ramp for a jump, you don't necessarily always want the poles to be right up hard against the start of the road mesh. Sometimes you want to push them back a bit. So that's why we've got 2 properties that we can set. So let's grab our small pole and put it underneath the spacing group so that it's spaced. And we need to add another component to the pole, and it's just called spaced. And the reason that we have 2 is often you want to have groups of objects that are spaced at the same interval, but they can have different properties, and we'll see how the is vertical and the z and x angles are used in a little bit. For now, we will take this pole position it perhaps 2.1, 1.1. Looks like it needs a bit of scaling, 1.2 perhaps. See how that looks. Looks reasonable. Once again, we can duplicate the object. I will just flip it over to the other side. Right, so if I update the whole track now, you might notice that in the upside down parts of the track there's no poles. And this is due to a setting in our racetrack space component. So we have a maximum Z angle and we have maximum X angle. And that refers to the maximum angle of the racetrack when rotated around the X or the Z axis. So for the upside down parts, the racetrack is rotated around the X axis. And we're saying that once the angle gets over 90 degrees, stop putting in the spaced objects. But in this particular case, we do want them for the upside down parts of the track. So we can simply change that to 180. And I need to make sure I select the other pole as well. And do the same If I just quickly update this one curve, you can see now it goes all the way through the track. Now the reason it defaults to 90 is because for things like supporting poles, you generally don't want to put a pole underneath the track that's upside down. It doesn't make a lot of sense. So speaking of supporting poles, that's what we're going to add next. So once again, we need to create an object, give it a name, support poles, and we add our Racetrack Spacing group component. And we're going to space them 20 units before and 20 units after, and leave the index set to 0. Now the reason we need two spacing groups is because the support poles are spaced at a different interval than the side poles. And the reason we have an index is to link the spacing groups between two different types of a racetrack mesh template. And that's important if we switch from one mesh template to the other. So it just keeps the spacing regular for the different types of things. So if we had, for example, support poles in one spacing group, and then we switched to a track template that had side poles in the same spacing group, then it's going to apply, for example, if you had a 20 unit spacing after the last support pole, it's going to apply that to the side poles, and that could introduce a large gap that you didn't really want. So it's important to organize your spaced objects into specific groups with their own unique specific indexes. Okay, so we're going to grab a pole, and we're going to grab it from Racetrack Builder Meshes Supports. There's a pole here, just drop it under there. That pole is rather large. Scale it down, scale the X and the Z by half. And we'll just adjust the Y so that it's flush with the bottom. And of course it's important to add the racetrack spaced component. Go ahead and update the racetrack. So something is not quite right. And we can see we've got poles going out at all sorts of angles. So what's happening here? And the issue is that the poles are aligned with the racetrack curves, which makes sense for these side poles. However, for the support poles, we want them to be vertical all the time. And that is where this is vertical property comes in. So we'll set that, and we'll update the racetrack again. So now, as we can see, the poles are vertical, but obviously there's something still not quite right. Now I have to admit, the first time I saw this, I thought there was a bug. But actually, as it turns out, it's actually Racetrack Builder doing what it's been told. So what it's doing is it's positioning the poles underneath based on the curvature of the racetrack, and then it's rotating them to be vertical. So the actual issue here is the center of rotation of the poles, and we can illustrate that by move that up a bit. So if we rotate our track type, say by 45 degrees, see the pole is rotated with it. We go to our support pole. If we were to rotate that back to make it vertical, we can see it is vertical, but it's no longer attached to our track type. So I'll just put that back. So what we need to do is make the center of rotation the top of the pole. And we can do that with a little bit of fiddling with the Unity objects. So if we create this empty object, just call it pole anchor. And in fact that needs to be inside the support poles object. So that object has a local position of 0, 0, 0. So that point there is going to be its center of rotation. And we can put our pole mesh inside that object. An important thing to do is we need to remove the spaced component from the mesh, otherwise that will simply become rotated again around its own center of rotation. I'm going to move it up into this new object that we've created. So we'll just move it there. Add our space component and just make sure we've set it to vertical again. And let's update our racetrack. Okay, so that's starting to look a bit better. However, still not quite perfect. Notice in steep parts of the racetrack we've got this issue. The top of the pole is pointing through, and the bottom of it is not flush with the racetrack either. You should also see it in a few different places. So to combat that, we're going to move the pole down slightly. And I'm actually going to reset the pole's Y position so that it's now flush with the top. And I'm actually going to move the anchor down. The negative 0.2 I believe makes it flush with the bottom, and we want to add, half a unit of that, so negative 0.7. And what that means is that there's room for the pole anchor to rotate without the pole passing through the road. Let's update our racetrack. Okay, so we can see that the poles are now below the racetrack. But of course it means that they're now no longer in contact with the racetrack, so they don't look like they're holding it up anymore. So this is a little bit of a tricky problem to solve. I mean, ideally we want the pole to go all the way up to the racetrack, but then we need to somehow carve the top of it to fit to the curve, and we don't really support that. So what we're actually going to do is cheat. So one way of cheating would just be to make the road thicker so that the pole can then intersect with the bottom of it essentially. So that would be one approach. However, the approach we're going to use is the same one that we've used within the default mesh templates that come with Racetrack Builder. And that's just going to be basically to add a beam underneath the road. And the pole is going to intersect with the beam, so it's going to push into the beam so that it looks like they're joined essentially. So we're going to add it inside the support poles object, and just use a standard Unity cube. move that down. I think we said negative 0.7. Scale it out. Switch to wireframes. You can see the pole is intersecting the middle of the cube, and I may make that a little bit wider as well. And I'm just going to call that beam. And because we want the beam to repeat with the pole, it's already inside the pole's spacing group, but it does need its own racetrack spaced component. And you'll notice we'll leave is vertical unticked for this one. So that's going to align it with the shape of the road. And that's one of the reasons we have a separate spaced component than a spacing group. Spacing group, placing everything underneath the same spacing group ensures that you always have the same spacing for things that are supposed to be together. But in some circumstances you may want to have different values for things like is vertical, and having two different components allows you to do that. And if we wanted to change the spacing of the poles, for example, we could change it on the spacing group, and then the beams would automatically get the same changes as well. So let's apply that. Okay, so let's have a look. So you can see that the poles are pushing inside the beams, but it gives the effect that they are actually joined together. And then because the beam aligns with the track, it makes it look all connected. So that's just one trick so that you can have poles underneath the track looking reasonably realistic. And of course the last thing to do is to take our new track type and turn it into a prefab. So I'm just going to select Racetrack Builder Prefab Track Templates, grab my track template type, drag it in, and we can get rid of it from our scene. And of course once again, because we've assigned it directly from the scene to the curve, just need to find it in our templates folder and drag the prefab there instead. And there we go. We've created our own template from scratch, and we've seen how to use the different components to describe to Racetrack Builder how we want it to use each of the meshes. And we solved a few problems with creating some support poles and making them look like they're holding up the track. So that's all for this video. Thanks for watching.